Okay, hey guys. Just want to start by saying I'm really nervous doing this, but it'll be okay. I wanted to go through some information with you so that you understand chemistry and I'm not just leaving you in the dark. As you can see, I am on Class Kick. We're all used to using this, so got to pick our favorite color. And I am on slide 74. So once I'm done with this video, I will leave everything here so you can look back at it and make that go away. We do have a special guest today, right here. That's my cat Mowgli. I made the picture really small so it wouldn't take up a lot of space, but he's there so I don't feel as nervous talking to absolutely no one. So I know I'm talking to you guys, but you know, I'm just sitting in my living room talking to absolutely, like, I don't have an audience, and I'm used to having an audience. But anyway, let's make that stuff go away. Thank you, Mowgli, for being my special guest. Anyway, okay, today we're going to talk about chapter 12. And chapter 12 is about this word right here. And it looks like it is Greek because it actually comes from Greek roots. So the word is stoichiometry. And stoichi, if you break it down, stoichi means elements. And metry at the end means measure. So that word, if you put it all together, I'm going to make that stuff go away. Well, no, I'll leave it. If you look at the definition, it says the calculation of quantities, and we know a quantity is something that is measured. So it's the calculation of quantities in a chemical reaction. Now, I want to point out right here that we are going to be using balanced chemical equations, and we learned how to do balanced chemical equations last chapter in chapter 11. And in this chapter, there is actually only one new thing, and I'm getting ready to cover that in a couple seconds. So anyway, stoichiometry is the calculation, so this is definitely a math chapter, the calculation of quantities in a chemical reaction. So once again, we are going to be using balanced chemical equations to help us figure out how much. So that's your quantity right there. And like I said, there's only one new piece of information in this whole chapter. And that new one piece of information is something called a mole ratio. Now, if you remember back in chapter 10, we talked about moles. And in that chapter, let me slide down here really quick. Ooh, I don't need that line. In that chapter, we talked about moles as a quantity. And we said it was like a map. And you could go to particle city, and you could go to volume city, and you could go to mass city if you wanted to. And all those were related through the middle quantity of moles. So remember, we have Avogadro's number here. We also have 22.4 liters in 1 mole up here. And then we have molar mass down here. And remember, that is calculated from the periodic table and molar masses. So we will be using the mole map again, but let me teach you the one new thing that we have to learn in this chapter really quick. I'm going to get all this stuff off of here so I can use it later because you don't need all that stuff on there. Okay, all gone. All right, so let's go back over here. Hey, Mo. Caddy. Okay, back to this. So let's go back here. and look at something called mole ratios. So we learned a while ago that a ratio was just something that could be written as like a fraction, or sometimes you would write it as like 2 to 1, or I don't know, 7 to 5, it didn't matter. Or you could say a ratio was also something like 4 to 9 would be a ratio. So those are just examples of ratios, and you already know that. But this is a special kind of ratio called a mole ratio. So a mole ratio is just a ratio, let me go back to my color, a ratio of moles from a balanced chemical equation. Now, mole ratios, if you look at this example right here, we have nitrogen and hydrogen react to form NH3. Here are some examples of mole ratios right here. If you look, you're probably saying, where did these numbers come from? See these numbers right here? Where did they come from? Let's erase this so we can see a little better. But look here. Remember, this is an understood 1. So we have a 1 in front of N2. We have a 3 in front of H2. And we have a 2 in front of NH3. Those are where these numbers come from. Like, look at this one, for example. This one right here. See how the 2 moles of NH3 for every 1 mole of N2. So we are using the coefficients to create mole ratios. Now, the reason we use mole ratios is to convert from maybe N2, like a quantity of N2, to a quantity of maybe H2. Because remember, units cancel out diagonally, and we can use these mole ratios to calculate quantities, either quantities needed from the reactants or quantities produced by products. In other words, if you see here, see how we have NH3 on the top and N2 on the bottom? We could use that to cancel out units and get to another unit that we might be looking for. Now, thankfully, I have already taught you guys how to do problems like we're going to do. So if we go down here, look, here's some example problems. Okay, so let's look here. Let's look at the first one. Once again, we have stoichiometry problems. Yay for us. So remember, that is elements plus measurement, or measures, I guess I should say, M-E-A-S, measures. So we're looking to find amounts here. So let's review our steps in order to do these problems. So I'm going to go up here and make a list of steps that we always use. I think we need to change colors. Let's go with this one. Okay, so steps. And these are steps we have been using or have already learned in the past. So the steps for these problems as a review is number 1, read the problem. Number 2, underline. the given one time. Number 3, double underline what you are trying to find. Number 4, start with the thing you underlined one time and convert, C-O-N-V-R-T, to the thing you underlined 2 times. Number 5, do math like magic. And number 6, add your units and check your significant figures. So using these steps right here, let's go down and try a mole to mole conversion problem using mole ratios. So your very first stoichiometry problem, let's do number 1 together. Okay, so step number 1 says, dun 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 dun. Ooh, read the problem. Okay, so read the problem. Got it. It says, how many moles of hydrogen are needed to completely react with 2 moles of nitrogen? Okay, I read the problem. Number 2, underline the given. Oh man, what is the given? So remember, with the given, we're looking for a number. Okay, how many moles of hydrogen are needed to completely... Oh, 2. 2, there's a number. 2 moles of nitrogen. Okay. See the third step. Double underline what I'm trying to find. Okay, so what am I trying to find? How many moles of hydrogen are needed to completely react with 2 moles of nitrogen? Okay, so there's what I'm trying to find. Next step, start with the thing I underlined one time. Okay. So what did I underline one time? 2 moles of, what was it? Nitrogen. Okay, so 2 moles of N2. And then it says convert to the thing I double underlined. Okay, so I'm going to use a mole ratio right here. I look at my balanced chemical equation. Now let's see. I have 1 mole of N2 on the bottom, because there is a 1 right there. And what am I trying to find? Moles of hydrogen. That's my double underline. So what's the coefficient in front? 3 moles of hydrogen. What cancels out? Moles of N2 cancel out. Now I have moles of H2 left. And that's what I was trying to find. So, let's get rid of the light pink stuff. There we go. What's my next step? Oh man, I don't know. Let's look back. Do math like magic. Okay, so multiply everything across the top. If we multiply everything across the top, 2 times 3 is 6. Multiply everything across the bottom. Divided by 1. 6 divided by 1 is 6. Next step. Units and significant figures. What's my units on here? My units are whatever I'm left with. So, moles of H2. So I have moles of H2. Now, significant figures. 2 has 1 significant figure, and 6 has 1 significant figure. There we go. That easy. Let's look at number 2 together. So, step number 1 says, read the problem. How many moles of oxygen are produced by the decomposition of 6 moles of potassium chlorate? Okay, so single underline the given. That's the second step. Let's check. Yep. Underline the given. Okay. So we're looking for a number. Here's a number. My next step says double underline what you're trying to find. So how many moles of oxygen are produced? The next step says start with the thing you underlined one time. So 6 moles of potassium chlorate. Oh man, where's potassium chlorate? Well, let's look at our balanced chemical equation and see if we can figure it out. Okay, so K is potassium and ClO3 is chlorate. So right there is potassium chlorate. Okay, so there's potassium chlorate. So KClO3. Now I'm going to do a mole ratio because I'm in moles and I can do a mole ratio right here. For my mole ratio, what I'm trying to cancel out has to go on the bottom, down here, and what I'm trying to find has to go on the top, up here. Get rid of those. Okay, so this has to be moles of KClO3, and this has to be moles of what I'm trying to find. I'm trying to find oxygen, so moles of O2. So, in our mole ratio, which is right here, I have to look at the coefficients from the balanced equation. That's where I get the numbers that go here and here. Why don't you take a second and see if you can figure out what numbers go here and here. I'll give you 1 minute. Okay. I know that wasn't a whole minute, but whatever. Okay, so we are going to look. What is the coefficient in front of KClO3? It is a 2. So we're going to put a 2 here. What is the coefficient in front of the oxygen? 3. Okay. What cancels out? Choop, choop. Now we are in moles of O2, and that's what we're trying to find from up here. So now we can do math magic. And we're going to multiply everything on the top. So 6 times 3 is, oh man, I have to get my calculator. 12 plus another 6, okay, 18. 2 times 1 is 2. 18 divided by 2 is 9. Last step says, I forget. Oh, units and significant figures. Duh. Okay. So, 6 has one significant figure. So my answer can have 1. And then I have to add units. So what units did I not cancel out? That's my units. So that's moles of O2. There we go. All right, I'm going to give you a minute. And by a minute, I'll really try and go like a whole minute. Why don't you try number 3? You try 3. Okay, let's look at number 3 together. It says, step number 1, read the problem. How many moles of hydrogen are produced from the reaction of 3 moles of zinc with an excess of hydrochloric acid? Now, whenever you see this excess of whatever, doesn't even matter what it is, it means please ignore me because I don't matter. So see, I just cross that stuff out. Doesn't matter. It's like story problems that talk about, like the bird on the house or whatever, and it's just like useless information. You don't need that to solve this problem. So whenever you see an excess of or blah, 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 nobody cares about that. Just ignore it. Don't let that get in the way. So if we look at this, I'm going to just cross that out with one line because I kind of made a mess. An excess of hydrogen. Nope. Okay, it says how many moles of hydrogen are produced from the reaction of, right there's my number, 3 moles of zinc. Got it. What are we trying to find? Moles of hydrogen. There we go, there's my double underline. Now, you always start with the given number or the thing you underlined one time. So we're going to start with 3 moles. Ooh, I don't like that. 3 moles of zinc. And then we are going to add our mole ratio. So we look up at our balanced chemical equation and we look for our coefficients. Now, what goes on the bottom? The unit we are trying to cancel out goes on the bottom. So it's moles of zinc. The unit we are trying to find goes on the top. So look at the thing you double underlined. You double underline moles of hydrogen. So moles of hydrogen. Oh wait, why is there a 2 there? Did you guys see I put a 2 right there? Like, see that little 2 right there? Why is that there? Because it just says moles of hydrogen. But if you look at your balanced chemical equation and you think back, remember, hydrogen is a diatomic. So we already learned that hydrogen was a diatomic. And if we look at our chemical equation, it's H2 up there. So when we write it down here in our mole ratio, it also has to be H2 because of that reason. So 1 more back, 2 more back. There we go. All right, so now we just need to figure out which numbers go in here and here. So moles of zinc. Look at my balanced chemical equation. What is my coefficient in front of zinc? It's a 1. What is my coefficient in front of H2? It is also a 1. What units cancel out? Moles of zinc. Done. I am in moles of H2. That's what the problem was asking me for up there. That's the thing I double underlined. So therefore, I have to do math magic now. 3 times 1. Ooh, that's not hard at all. That's 3. 1 times 1 is 1. So my answer is 3. Last step, significant figures. How many significant figures is in 3? Only 1. So I can go 3 units, moles of H2. All right. So now if you look at this, you have 2 more problems to do on your own. Number 4 and number 5. I just want to caution you down here on number 5 as just a quick preview. Let's read this together really quick. It says, how many moles of potassium nitrate are produced when 2 moles of potassium phosphate react with 2 moles of aluminum nitrate? So what this problem is saying, there's kind of a little twist here, but it's not that hard. It's saying you have 2 moles of this and 2 moles of this. How much of this can you make? So this problem is no different than what we've been doing. It's just you have 2 givens, so you have to do 2 problems. So in other words, you would start out by going 2 moles. Oh, I'm going to try and write small. No, I don't have to write that small. Okay, so 2 moles of potassium phosphate. And then you have another problem down here with 2 moles of aluminum nitrate, NO3, and then you just do 2 problems with 2 mole ratios. That's all you do. So 2 problems, 2 mole ratios, and you're converting to moles of potassium nitrate. So I am going to let you go. If you have any questions on these 2 problems that I've asked for you to do, please email me those questions and I will respond to them. And stay tuned for other videos, which will be coming shortly. Thanks, guys.